students, this is Ramesh and along with me my colleague Rajendra sir. We are going to give the analysis on the EDC, like how to prepare for the examination, like for the GATE and ES and IES, and for that particular point of view, what the way we have to prepare and what are the contents present in that topic, in that particular subject, and the marks weightage and the analysis of such type of things we are going to give now today. And as far as this weightage is concerned, Rajendra sir is going to give the analysis of that one.
Hello everyone, I am Rajendra Kumar. So regarding the EDC subject, which is the most important and basic subject, if you are thorough in the basics, the advantage is you can analyze and design the analog subject followed by the digital electronics. So whatever be the electronic subject, the EDC will play the major role. If you analyze right from 1999, both for the GATE and IES, every year the weightage of marks for the EDC subject gradually increasing.
Yes sir.
Right, and today we are getting around 25 to 30 marks from the EDC subject alone for the GATE and IES. But according to the new syllabus pattern of IES and GATE, if we analyze in a GATE exam, we got about 10 marks, and all these 10 marks, I mean 5 questions, we got it from a single chapter, and that is your PN junction diode. Right, entire questions have been concentrated only in one particular chapter, that is the PN junction diode. Whereas if you see the IES 2018 question, the questions are evenly spread on the basics, followed by one question from PN junction diode and one question from FET and one question from introduction to the transistors, like this.
Yes,
now
sir.
my friend Ramesh will continue.
Actually, the sir said the same way we are having. Sometimes we are going to give. They are going to give the questions all from the one particular chapter, and sometimes they are going to give distributed way. That's why we have to prepare all the topics. We have to give the importance to all the topics in an equal manner, because sometimes sir said in the same manner. This year they gave only on the PN junction diode, and last year they gave on the semiconductor physics, and sometimes they are focusing on the FET MOSFET, like that. That's why. But marks weightage is more, but equally they are giving importance for all the subjects, but not single year. 1 year in one particular one particular topic, and another year in another particular chapter, like that. That's why as far as the preparation is concerned, we should prepare all the contents and in an equal important manner. Otherwise, in a particular chapter if you prepare, you will miss in another chapter, then it's going to be loss only. That's why you should have thoroughly preparation by giving importance as far as the preparation is concerned in for all the chapters in an equal manner.
So many times in the class, students are generally asking how to prepare for the GATE exam and IES exam. So my sincere advice to all of you, please please take down the running notes in the class, and later when you go to the home, prepare a micro notes, so that the entire first unit, second unit, third unit and fourth unit of the EDC try to accommodate in one page for each topic, so that whenever there is a time, you just scan that 4 pages, so that entire EDC subject you can revise in half an hour or 1 hour. Right. Otherwise, if you want to read the entire notes of the EDC given by the faculty, it will take more than 2 or 3 days. Right. So always, to crack the competitive examinations, micro notes is very essential.
Yeah, as sir told, no, that some microscopic view contents should be noted down, because when teacher is saying in the class, so many microscopic view contents he will say, because as far as this EDC is concerned, especially, it is the more conceptual based. Based on the physics, it is a developed subject of the electronics, no, it is more focused on the concepts of the physics. So when teacher is saying in the class, so many conceptual matters he will say in a microscopic view manner. So when you are not noting down those microscopic view contents, if the questions asked based on that, as sir said, no, the first chapter is actually more conceptual matter. So when you are missing or skipping certain points to note down in a microscopic manner, then it is going to give trouble to you. That's why you should note down those microscopic contents in a notes wise like that.
Now suppose if you take the gate examination, gate exam is more problematic. 90% of the questions will be only problematic and 10% theory questions. So if you really want to crack the gate examination, compulsory you have to do a good number of problems solved in the class and also at home. So whereas if you take the IES examination, it is 90% theory and 10% problematic.
Yes, right.
Right? In IES exam, calculator is not allowed, and also you have to tick the OMR sheet. Thereby, usually the questions are theory based, and also
right.
if a problem is given, that problems are generally one equation and one unknown. You can easily manually calculate and put up the answer.
And these problems also, sir, as you said, the thing is correct, sir, that problems also, if they are not having the knowledge of the conceptual matter, then they are not able to focus on the formula also.
Yes.
That's why the concepts also really they have to be perfect.
Perfect.
Yeah.
Unless you know the theory, you cannot solve the problem.
Yes,
the
sir.
reason theory is more associated to understand the solution of the problem.
Yes, sir.
Right? And also regarding the workbook, give the importance to the workbook. Right? Many questions which we are taken from previous papers and also from different textbooks have been given in the workbook.
Yes,
really, the questions of the workbook are highly standard wise.
Yes, sir.
So go through them,
yes,
right? Do the problems and analyze the theory and prepare for your exam. My sincere advice: never neglect the workbook for the examination.
As far as this workbook is concerned, every problem is a unique problem. We haven't repeated the number of problems like that. Every problem is a unique problem. That's why when you are going through that particular workbook, definitely all the contents and all the particular concepts are going to be, we can have thoroughly revised manner. That's why you should focus on the workbook also more and more.
Now let us analyze the EDC subject topic wise. And regarding the first chapter, it is the basics, and my colleague Mr. Ramesh will continue.
Yeah, as far as this first particular chapter is concerned, which we are going to say as a semiconductor physics, it is going to have so many concepts and so many basics, the fundamentals of the physics like, and these are so much important also. We can say it is the roots of the subject of the EDC, because as far as this EDC subject is concerned, first we should make the horizontal expansion of the subject, then only we can go for the vertical expansion. As far as the vertical expansion is concerned, like devices starting from the diode, BJT, FET, MOSFET, and further vertical expansions like circuit theories and all. For all those things also, this particular thing, the roots of the subject is nothing but the semiconductor physics, the first chapter itself, because it contains more conceptual things starting from the energy band theory. Now we will make the analysis of the semiconductor physics, how to prepare it and what are the contents present in that and what the way you have to make the preparation and all like that. Yeah, the first chapter is the semiconductor physics. We are going to focus on that. We are going to make the analysis of the semiconductor physics along with the sir. And as far as the semiconductor physics is concerned, the movement of an electron inside a semiconductor is nothing but the study of that particular subject is nothing but treated as electronics. That means inside the semiconductor how an electron is moving, and while an electron is moving, what are the consequences we are getting there. All such type of analysis is nothing but the subject of semiconductor physics, which is treated as electronics. That's why the movement of electron inside the semiconductor, that we should understand and we have to focus on that particular point. And for that, the first thing we have to learn in the semiconductor physics is the energy band theory. And the energy band theory also we should understand clearly about how these bands are formed and what is the way we are making the classification of the materials and all. Because when you are going to the further contents like gun effect and such type of certain things, when you are understanding, when we are trying to understand them like conduction band minima, valence band maxima, such type of certain things are going to give trouble to you. That's why first we should understand how these bands are formed more clear manner, then only we can understand such type of vertical expansion things like gun effect and all. And as far as this material classification is concerned, once we are categorizing these based on the linear combination of these atomic orbitals and all, then we are going further things like the semiconductor focused things like what are the categorization of semiconductors, what is the intrinsic semiconductors and extrinsic semiconductors, and also like elemental type of semiconductors and compound type of semiconductors. You don't miss anything in the even in the compound type of semiconductors also, because in these days in the compound type of semiconductors also they are asking the questions like it is having like the doping in the N type and also P type, both when they are trivalent and pentavalent impurities are added in that, then what is the result of the material, and based on that the problems also asked. No sir, recently they asked also like
compensated semiconductors. Frequently nowadays this topic is getting more and more importance.
Yeah, so we should focus on the compound type of semiconductor materials also. Like after that these donor levels, acceptor levels, these things also very clearly we should understand where these are actually formed, and because based on these in next we are going to have the discussion of the Fermi levels and all, because when we want to understand about the Fermi levels topic, we should thoroughly know about the donor levels where they are going to be formed and acceptor levels where they are going to be formed, and based on them how the Fermi level is defined and where it is going to be formed, like that, because the Fermi level is a very important topic as far as the exam and conceptual point of view is also concerned. Isn't it sir, the Fermi levels?
Fermi level will also play a very important role when you analyze for mass capacitor. There also the energy band diagram of the mass capacitor is important. If you want to analyze, understand the mass capacitor, compulsory you know the fundamentals of band theory and Fermi levels.
Yeah, like the vertical expansion things like sir said, no, the way mass FET and such type of things when we are discussing, there also we are going to get this particular Fermi level discussions. That's why this first chapter, the roots of the subject of the vertical expansion, we should not miss any particular point like Fermi-Dirac distribution functions, and based on the Fermi-Dirac distribution functions we are able to get conceptual based the questions of the 2 marks also sometimes we are going to get in that, even for the objective also. In the GATE and even for other competitive exams also they are focusing on such type of things. And one more thing is also there, like when you are having the Fermi level discussion, especially the effect of temperatures and doping levels are based on that also they are asking the questions, no sir, like when the effect of temperature, how it is going to be on the Fermi levels, like doping when it is made, how the Fermi level is going to be shifted, such type of things also they are focusing. That's why we should thoroughly know about such type of things. And before that also we are having certain derivations parts in the first chapter. Even for the objective also some people will think about what is the need of the much derivation part of the first chapter when you are going for the GATE and such type of objective papers only. But it is wrong thing their analysis, like because there will be some mother derivations like energy band theory is a mother concept we can say for overall so many of energy levels, no sir. Like that only the intrinsic carrier concentration Ni, the derivation part also we have to focus, we have to understand first of all how they are analyzed and how they derived and all. Once we are able to understand such type of thing of derivation part of the intrinsic carrier concentration, then based on that the number of formulae, the first chapter having so many formulae, all those are generated from the first chapter mother derivation of intrinsic carrier concentration only. That's why we had to focus on the derivation part also. Just one time we had to make the analysis of that. Afterwards, once when you are able to understand how it came, from that all the formulae derived, then you will have so much confidence in you while you are using those formulae for the objective preparation. And next contains like the electron, how it is going to have its velocity variations in the say normal elementary type of semiconductors and in the compound type of semiconductors, like in the silicon and germanium, how an electron drift velocity is having the variations with the electric field, and the drift velocity variations, how it is making the difference in such type of compound type of semiconductors like gallium arsenide, indium phosphate, such type of things. So because based on that also in competitive exams, conceptual based questions they are asking. In these days the depth of the subject is also, as far as the conceptual matter is concerned, they are going to the deep level only. That's why we should focus on that, because they are able to ask even one particular thing like when it is shifted from one valley to the another valley, what is the effective mass, how it is changing, such type of questions also they are asking. So when we are focusing such type of velocity, drift velocity analysis with the electric field, we should focus on this particular valley structures also as far as the compound type of semiconductors are concerned. Because what the way they are going to the deep level, you can see one particular question in these days, like they asked about surface states also, no sir.
Yeah.
Certain times they are going to the deep level, it is better to focus on deeply only, from the roots to the deep level of the subject. And these things are continued, like we are having the drift velocity, and after that the drift currents, diffusion currents, and such type of things also. Drift current, diffusion current based, definitely you will get a question like that in the first chapter if they ask the questions, isn't it sir, the diffusion currents? And
generally we get calculate diffusion current density in the N-type and P-type semiconductors. It's a common question.
Yes sir, right. Just like that the derivation parts of the drift diffusion currents, based on the formulae we have to remember, where it is required like thermal voltage also, and Einstein's relations also, and recombinations, generations of the electron holes also, related small formulas are related that also. Yes sir.
And one more is continuity equation.
Yes, based on that the fundamental contents based, the formulae based, they are going to ask the questions. But to understand those formulae, the conceptual matter, you should have the perfectancy in that, then only you can get the succeed in that particular problematic part of the first chapter. And in one more thing also there, you may are having some idea about the electric field intensity. Regarding to that electric field intensity also, that when electric field is applied on a particular semiconductor, how the energy levels are having the variations, and then what is the resultant current in that, the like the drift current, diffusion currents. So based on that also we are getting the questions, no sir, in these days.
Yeah, and field intensity calculation problem is a very common problem for the gate examination. A semiconductor is given maybe with uniform or non-uniform doping, right, and they will ask you what is the, how to calculate the diffusion current density and drift current density is there.
Like then we should understand about what is the built-in electric field, how it is going to play the role when applied external electric field is there. Such type of things also we should focus. And one more important topic is there in the first chapter, like the carrier injection. That means they are taking a particular semiconductor and they are going to focus the light injected on a particular end, then how we are going to have the diffusion, drift currents and all. Even they are going to make the heating up at one end of the semiconductor, then how we are going to get the currents, the variations, the drift diffusion currents, no sir, like that also they are asking the
effect of light topic is very important. Problems are generally asked from here, right?
Yeah. And in the first chapter we are having one more very important topic, like that is the Hall effect. And the Hall experiment related questions definitely you can expect in the examination. To understand about the Hall effect, it's purely the physics based only. The first chapter itself, we should have the so many fundamentals and so many small contents only. Based on that we are going to build a particular overall experiment of Hall experiment, like that. So when we are trying to understand about the Hall experiment, we should focus on so many Lorentz form rules also, such type of physics formula related. But those are going to give a very good result to you in the examination as far as the Hall experiment is concerned. Because in the Hall experiment we are going to get the questions like phase 1, phase 2 of the semiconductor. Phase 1 is this particular charge came, then what is the type of semiconductor, how can you identify that semiconductor, whether it is a N type or P type, such type of things also we are able to get the questions in the Hall experiment. To understand about it, we should be perfect about the physics fundamentals also. That's why when teacher is saying in the class about so many physics fundamentals which you are not having directly in the engineering, which we are having in the plus 2 level all, but those also when teacher is going to say, because teacher definitely will focus based on those things only, he will come to the real content of the subject, then we should have a clear understanding of that, and we should understand and we should note down such type of things. Yeah, the second chapter is the PN junctions, and regarding to that, sir will focus on that.
Now if you consider any semiconductor device, it is basically a PN junction.
Yeah.
So what is a PN junction? The importance of the PN junction, how the junction is formed, right? What is the depletion layer and why the depletion layer is created, and what are the properties of the depletion layer, and what is the contact potential, the importance of the contact potential, and what are these numerical values of the contact potential for your germanium diode and silicon diode. We have to give the importance. And what are the current components in an unbiased PN junction diode, we have to analyze. And what is the equilibrium current in the PN junction diode. Later on, how the current will pass into the PN junction diode by applying some biasing. So we have to now analyze the different types of biasings like forward biasing and reverse biasing. When PN junction is reverse biased, there will be some current, right? This current is mainly due to what? What type of charge carriers, how the current is contributed in the reverse biased PN junction, and how the temperature will affect this reverse bias current, what is the direction of the reverse bias current. These things we will analyze under the topic.
Sir,
right.
Directions based also questions
Yeah.
asking, sir.
When you go for PN junction operating under forward bias, how the current is carried out. The forward current is due to what? It is based on what type of properties of your device, and the equation for the forward current, right? And a problem we have to analyze on the equation of forward current of the PN junction diode, right? Under PN junction, how the charge carriers are moving from P to N and N to P. Is it due to majority carriers or due to the minority carriers, and the importance of injected minority carrier concentration, right? Whether the forward current, is it a drift current or a diffusion current. These things we have to analyze under the PN junction diode. And later, when the PN junction is reverse biased or forward biasing, there is a junction capacitance, right? Junction capacitances are of two types. One is CT and one more is CD. So the importance of the CT and importance of CD will come when you analyze the amplifier topic, that is in analog subject.
Even
Right.
they are asking questions in that CT, CD, no sir, derivation part.
Derivation, not derivation, but problem is asked.
Problems.
Problem is asked. But importance of junction capacitance will come only in the analog, right? And without that, it may be very difficult for you to analyze the amplifier properties at high frequency applications, right? Then we have to plot the VI characteristics of PN junction diode. Then we have to analyze the diode resistance both under forward bias and also under reverse bias. What is the static resistance and what is the dynamic resistance, right? And how to calculate them, and different types of problems when it is under forward biasing, under reverse biasing are very important. Under unbiased condition, how to analyze the width of the depletion layer, how to solve the problems. These will play the major role when you go for the gate examination.
It's very important also.
Yeah, frequently
Yes, sir.
questions are appearing from this
Yes, sir.
area,
Right, sir.
right? And later we have to analyze the different types of semiconductor diodes. For example, if you take step graded diode, what is a step graded diode, and how to calculate the depletion layer width on the lightly doped side,
Yes.
and what is the equation for the total approximate depletion layer width. This will play the major role, right? And also the electric field intensity diagram of the PN junction diode, how to apply Poisson's equation and calculate maximum field intensity at the junction.
So the diagram based also question.
Diagram based. These questions are very frequently appearing in the GATE examination and even in the IES conventional paper. This will play the major role. Right. Then we go for the other device, photodiode. Right. When light is focused on the PN junction diode, I mean photodiode, how the device will be working. Right. What are the properties of the photodiode? Right, and photodiode current, how it is created? Is it a drift current or is it a diffusion current? And one more regarding the dark current of the photodiode will also play the major role.
Yes, sir.
Right, so applications of the photodiode is important. And one more, the essential features of the photodiode is also very important for better performance. What are the properties we analyze? Then we go for LED, light emitting diode. Right, in this, what are the properties of the light emitting diode? Will it emit the light under visible spectrum of light or invisible spectrum of light, and where we are using the LEDs?
Yeah.
Okay, and one more, in LED, we generally get only the theory questions, that is based on how the LED will be operated. I mean function, internal behavior of the charge carriers in the LED is important topic. Later we come across the solar cell. Right, since 3 years continuously we are getting one question from the solar cell. Right, the reason government is in favor of the solar system in our country. Based on this, in the GATE exam, every year we are compulsory getting one question.
The present application.
Yeah, 3 years we have successfully got a question from solar cell, and even we are predicting the same one more question from solar cell in 2019 examination also. Right, and I wish all my students compulsory concentrate on the problems of solar cell and get ready to score the 2 marks from this chapter.
Yeah,
Right.
as
Now
sir
my
said.
colleague will continue regarding the other semiconductor device.
Thank you, sir. As far as this sir said, no, the same way, once you are able to understand the PN junction thoroughly, like how you are having forward bias and how you are having reverse bias, just not like in engineering what the way you learn, like simply electrons are moving from N to P, holes are moving P to N, not just like that. We should understand clearly in the energy level diagram also, from where to where electrons are having the moment and where to where the holes are shifting through the energy levels with the help of energy band diagrams. Then only you will get the clarity about the PN junction. Once you are able to get the clarity about the PN junction, then based on that all other semiconductor diodes easily we can understand that, like LED, all such type of things you can understand once you are able to know clearly how electrons from where to where actually in the energy levels they shifted. Like that only the metal semiconductor contacts based Schottky diode also you can have the clear content about it, concept about it, because sir it is useful in the MOSFET also, no sir, the metal semiconductor contact.
And also
related.
point contact diode also.
Yes sir, related to the Schottky contacts only. That's why once you are able to understand the PN junction thoroughly, you can understand all such type of various diodes.
Now my colleague Ramesh will continue with the third chapter, that is the bipolar junction transistor, that is BJT.
Right. As far as this particular BJT is concerned, once you are able to know about the PN junction in a clear manner, then based on the PN junction only, the minority carrier current, how it can be increased and how it can be under control is going to be discussed in the BJT. So PN junction you should have the clear knowledge about it. Then the NPN and PNP transistors in that we are able to understand such type of things. And we should focus on the BJT more on theoretically, like ICBO, and alpha, current amplification factors, such type of things. Then based on that we are able to handle the questions.
And also the internal function of the BJT can be analyzed only from the basics of PN junction diode.
Yes sir, real sir.
Right. Without having any knowledge on the PN junction diode, it is very difficult to analyze the properties of your BJT.
Because
in fact,
yeah.
BJT analysis is done in terms of diode analysis.
Yeah, because the PN junction microscopic view, if I are able to understand clearly, sir said, no, the same contents we are going to apply in the transistor also, so that clarity will get more and more. Once you are having the knowledge about the PN junction, then the other devices will be very easy. Then now sir will focus on the FET and MOSFET related to that, the focus and analysis and how to prepare about FET and MOSFET.
Yeah. Regarding the JFET. The topic of the JFET is more important only for the IES examination. And in the IES preliminary exam, you may be getting a very small problems on the JFET, where we have to use without calculator, and these problems are always one equation and one unknown.
It's not there in GATE syllabus.
And JFET is not there for the GATE examination. Yes. And regarding the MOSFET, in the MOSFET, the most important topic is the mass capacitor, right? How the mass capacitor is created, right? And how the energy band diagram of the mass capacitor will be plotted, and what are the properties of the mass capacitor under different modes of operation, just like accumulation mode, depletion mode, and inversion mode, right? And what is the importance, and how to convert a mass capacitor into the MOSFET, how to convert. These points are very important, and without understanding a mass capacitor, it is very difficult to understand the properties of the formation of N channel or P channel E only MOSFET. Mass capacitor will play the major role. In the latest papers of the GATE and IES, many times we are getting problems on mass capacitor. For example, calculation of gate voltage.
So
Right.
one more thing also there, like gate voltage applied, how these levels are shifted, bending
shifted.
and all, based on
Right.
that also theoretical
Yes.
questions.
Band diagrams are important. Based on band diagram, how to calculate space charge width, and how to calculate maximum space charge width.
Yeah.
These questions are very important, right? And regarding the properties of the MOSFET, right? How the MOSFET is working, right? Internal behavior of the device, and what is channel length modulation, what is the effect of channel length modulation on the performance of your MOSFET.
Even problem also getting formula based on channel length modulation, no, sir?
Problem
One
is very
comparison.
difficult to get, but theory questions are generally asked on the channel length modulation. And regarding the threshold voltage of the MOSFET, this topic will play one of the major role, right? For better performance, threshold voltage must be small as possible. So what are the advantages of having a smaller threshold voltage? These things are very important. What is the gate material used in the MOSFET?
Yeah.
Right. These are very important topics.
To get the less threshold voltage, what are the things we should apply?
How to reduce the threshold voltage?
Right.
This is one of the standard questions. What are the various techniques we are applying to reduce the threshold voltage? Mainly, you may get a theory question or you may get a problem. But for the GATE exam, my choice, you have to do more number of problems. Take the Neiman textbook and do the maximum problems from the MOSFET chapter, right? Always go for the solved examples from the Neiman textbook and prepare as many problems as possible from the textbook. Even the solutions of Neiman is available in the market. So take the solutions and do the maximum problems. Though we are doing a good number of problems from the workbook and also in the class, it is your responsibility to add some more questions from the MOS chapter and add up into your notes.
Especially on the mass capacitor related.
Particularly. And one more, in the GATE exam, according to the latest trend, you have to concentrate on the area where questions never appeared in the previous examination.
Yeah.
That is very important. Just like XD calculation, XDD calculation, these problems never came So give the importance so that there is a chance you may be getting a very good marks from the MOSFET. So these are the most important points regarding the MOSFET. So overall preparation of the EDC is very important, and try to revise the subject at least once in a month, so that by the time you get the GATE exam or IES exam, you may be completing about 6 or 7 revisions, so that you will be having a good command on the subject of EDC. So I wish all my students a best of luck and prepare the subject well and come out successfully in the examination, right? Best of luck.
Yes, just sir said in the same manner, the microscopic view you should focus in any of the topic also, and all the best, and definitely you are going to be succeed. Right, thank you.
Thank you.